Alright, this video is for worksheet 2-4 for the class Discovering Exponents and Polynomials. So you can see I did a little work. That's because I started recording this video and then there was an error and a bunch of stuff. So there's already some work in here, but we can get started with this. Please pause it and grade your work. And I am going to get started. So I hope you've paused because I am now going to zoom in and start working on some of these problems. So by now we know how to find a radical. This index, which if there's nothing there is a 2, tells us how many times to multiply it to get to that. Well, I have to multiply 9 twice to get to 81. This one tells me what do I multiply 3 times to get to 8, and that would be 2. This one says what do I multiply 4 times to get to 625, and that would be 5. 5 multiplied 4 times will give you 625. All right, so the power rule says that when you raise a power to a power, you just have to multiply those powers. I wanted to show one where we actually model the rule so you can see it. So inside the parentheses, I have 2 times 2 times 2. Well, that's 8. Then if I do the one on the outside of the parentheses, that would be 8 times 8, right? 8 to the second power is 8 times 8, which is 64. Well, if I do the power rule, it's 3 times 2, which is 2 to the 6. To the 6 is also 64. So it gives us the same answer. So we can shortcut it by just using our power rule now that we know why it works, and we can just multiply our exponents. After we do that, it's just calculator time. Not going to make you come up with something that is a million. All right. In this one, we have 2 negatives. Remember, 2 negatives multiplied together gives you a positive. So it's going to be 5 to the 6th power. All right. In this one, everything gets the 2. So the 2 gets the 2. The y gets 2 times 2. The x gets, that's a 1 times a 2. So 2 to the 2nd power is 4. 2 times 2 gives me y to the 4th and x to the 2nd. See here, I kind of gave you the unsimplified version to help you out. Everything gets the 4 on the inside. So if I do that, I get this. So 3 to the 4th is 81. T, 3 times 4 is 12. And R, 5 times 4 is 20. All right, for this one, everything gets a -3, which means it's all going to go negative. It's hard to figure these out. If you put 7 to the -3 into your calculator, you got a decimal, a very small decimal. That is because it's less than 1. We approach as close as we can to the origin, but we never quite cross 0. So we could also write this with all positives by putting it on the bottom of a fraction, right? Because it's less than 1. It's a number less than 1. That's plus. All right, and in this case, this scenario, I could actually put 7 to the 3rd power in my calculator, and that will give me the 343. All right, so everything gets the 4, so x 2 times 4, y, there's an understood 1 times 4, so that's going to be x to the 8th and y to the 4th. Everything gets the 2, so 2c to the 2, d to the 8th. Then this one, everything gets a 5, so c to the 5th, d to the 5th. Now I got to get my like terms together. Ooh, I forgot to put my 2 on my 2. So that's going to be 4. Now I have to use the product rule, which means I'm adding. All right, so I'm doing c plus 2 plus 5 and d 8 plus 5, which will reduce down to c to the 7th and b to the 13th. All right, so everything gets the 4 applied to it. Okay, so 2 to the 4th, f to the 4th, g to the 16th, because 4 times 4 is 16. Everything gets the 6. So f to the 6th, g to the 6th. Okay, let's clean this up. 2 to the 4th power is 16. Now I got to do the product rule, 4 plus 6. And for the g, 16 plus 6. My final answer after I do all that, oh, am I? No, I'm not wrong. G to the 22nd. So basically what the power rule is doing, all right, is it's expanding the multiplication. And then that is what's inside the parentheses, right? And then I have to do that 3 times. So it's expanding the multiplication multiple times. Okay? It's taking something that's already repetitive multiplication and making it even more repetitive multiplication. But if I add everything up, I still have 6 x's, which is the same as if I were to multiply these two. All right? So the rule is faster than the modeling, but you can see from the modeling how they get it. You expand it and then resimplify it using the rule. All right, do that till you master it. Let me know if you have any questions or need any more work, and I'll see you in class.